Okay, I'm back, and now we're going to do part 3 of the lab, which is how to calculate currents, voltages, and resistances. So we've measured it using the voltmeter and the ammeter. There's actually even another type of device, a multimeter, that can measure resistances, but they don't have that in the simulation. So we can't actually measure the resistance of the resistor, but we could do the current and the voltages. So if you look here, here's a summary of what we know so far. So we set the resistance to 12 ohms, and then we set the voltage to 15 volts, and then we measured the current, and so I went ahead and put it in here. So it's 1.25. But you notice that there's a blank spot underneath here. So we want to try to calculate what is the electric current. And so in order to do that, we're going to use Ohm's Law. So this is named after the scientist by the name of Ohm. And so he was so famous that he got a unit, a metric unit named after him, the ohm. And so the formula is going to say that V for voltage is equal to I for current times R for resistance. So we're going to use that formula. So notice that you know the resistance. So the resistance is going to be 12. Now, whenever you do a math problem, okay, you always want to try to do it the same way. You're going to write down what are you given and what are you looking for. And we start by writing down our numbers. So notice that we've got a number, let's put it up here. So we've got a number 12, and then it was a resistance, so it had the unit of ohms. We have this number 15, and it had the unit of volts. And then I'm going to put down a question mark, and so that is what we're looking for. Okay, now the next thing that we're going to do is what letter represents the 12 ohms. So ohms is a unit of resistance, so that's going to be the letter R. And then V is volts, so that's a unit of voltage, so that's V. And then we're looking for the current, because that's the thing that we don't know. So we're pretending that we don't know what the current is. So that means that we're looking for the letter I. Now, why do we want to do this? Okay, the reason why we want to do this is it helps us not to get our numbers mixed up when we put them into the formula. Because the next step is you say to yourself, do I have a formula that has an R, a V, and an I in it? And yes, we do. That was Ohm's Law. So then the next step is to take this material and put it in here. So we know that the voltage is 15. Now, I don't need to put the V in there, so I'm just putting in the raw numbers. Now, you can if you want to. So if you want to put 15V, that's fine. And then we don't know what the current is. And then we do know that the resistance was 12. So it was 12 ohms. So that's what we need to solve. Okay, now we're going to do opposites. So when we take this and this, we are doing what to them? We're multiplying them together. So the opposite is division. So we're going to divide both sides by 12. So then we end up with 15 divided by 12 is equal to the current. And now we need to get out our calculator. So you need to take 15 divided by 12, and then that turns out to be, well, I'm not going to tell you. You should know what that is. So go ahead and calculate that with your calculator, and then put the correct unit next to it, because it's a current. So therefore the official metric unit for current is the blank, and then put that on there, and then you can put that here. Now notice you don't need to put the unit on here because it's up here. So that's why I put the symbol for current, and then I also put down the unit for current up here, and I do the same thing for the voltage and for the resistance. So that means that these numbers here, they can just be regular numbers. And I do that because sometimes we're going to graph, and when you go to graph using the computer, you cannot put any units in there. Okay, now it also is going to ask you to predict what's going to happen to the current if you were to increase the voltage. So let's take a look at that for a moment here. So I'm going to erase all of this, and then let's just go back to this formula here. So now this is going to be conceptual because we're not really putting numbers into it. We're just asking what happens if we increase the voltage. So we're going to increase the voltage, and the question is what is going to happen to the current. Now we're not going to do anything to the resistance. So you see that the resistance is still the same, but we've increased the voltage, and the question is what's going to happen to the current. All right, now in algebra you should know that if you multiply one side of the equation by a certain number, you have to multiply the other side of the equation by the same number. So let's say that I double the voltage. So the voltage got bigger, so let's say I doubled it. So that would mean I'm going to double the V, so I have to double the other side over here, but I'm not doing anything to the R. So it's not the thing that's going to get doubled, it's going to be the current that is going to double. So if the voltage increases, then the current, okay, and you go ahead and put that into the lab. And then the next question says, well, what would happen if instead of increasing the voltage, I increase the resistance? So in this case, I'll go back to here, and I'll just put in a regular V. So I'm trying to make this V the same size as that V. I did not succeed, but anyway. The voltage doesn't change, but this time what I'm doing is I'm making the resistance larger. And the question is what happens to the current? Okay, now in order to figure this one out, think about that 4 is equal to 1 times 4. But it's also equal to 4 times 1. So you notice that a little number times a big number can be the same thing as a big number times a little number. So what we're doing here is we're making this number here bigger. So this number got bigger. So therefore, what did this number do in order to compensate? Okay, and then take that and then answer the question down here about that. So those are just some conceptual questions about Ohm's law. Now also, I would like for you to, it would be helpful if you would go to your lecture notes. So do you remember this one here? So lesson 21 on electrical current. So this is your PowerPoints for lecture. And if you go down through this, then you'll notice that I discuss what is electrical current. And then I discuss what is electrical voltage. So we talked about this in lecture. So I've got videos for all of this. So if you just want to go and watch the videos that goes with this lecture. I explain everything. And then I explain what resistance is. But here's the important thing. So here is Ohm's Law. V equals IR. And you notice the way I got it written there is V equals RI. Makes absolutely no difference. So you can take the I and put it in front of the R or vice versa. And then here is a worked out example of how to use Ohm's Law. So you might want to review that. Alright, so now if you keep on going down, we're at series and parallel circuits. So you might want to go to there in your notes because it'll be very helpful, because we are just about ready to begin series circuits. But that is part 4, which we're going to do next time. So remember that we're doing lab number 1 was parts 1, 2, and 3. And now when I come back, we're going to start on the second lab, which is parts 4 and 5. So I will see you then.